Okay, now members, we are going to concentrate on resolution of forces acting on polygons. We have been seeing forces which are acting on particles. Now we are going to see for polygons. Now basically we are going to concentrate on regular polygons. What do we have there? For regular polygons, all sides are equal, that's one. All interior angles are equal and all exterior angles are equal. So for example, we can have a square, we can have an equatorial triangle. So it's that all sides are equal and all interior angles are equal, and so the exterior angle. So let us go through this question here. If this is an equatorial triangle, forces this and this act along AB, BC, and CA respectively. So we first construct our equatorial triangle. You get your ruler and you construct your equatorial triangle with ease. So I'm going to construct that one to be mine. I'm assuming that all sides are going to be equal. Okay. Okay, so that is my equatorial triangle. Of course, equatorial triangle, all angles are equal. And if this one is a three-sided polygon, it means that to get the interior angles, you get 180 divided by the sides of the polygon. So 180 divided by 3, we shall get 60. So these are 60 degrees. This one is also having 60 degrees. And also this one is having 60 degrees. So the thing is that forces 12, 10, and 10 act along AB. So if I call this one my A, and I call this one my B, of course this one will be my C, to complete the whole triangle. Act along respectively. The directions of the forces are being indicated by the order of letters. Now, you know forces should be having direction. So, I think that's a when they tell you AB, that will be the direction of the force. So now, I think that's the 12 will go with AB because the orders respectively. So, AB, now our direction of this force is going to be like that. This one is going to be 12 newtons. Then BC is going to be 10. BC is going to be 10 newtons. Then CA, our CA is going to be also 10 newtons. As simple as that. We are starting with the basis. Indicated by the order of letters, find the magnitude and the direction of the resultant force. Now, in the resultant force, we've been seeing how we resolve the forces. We depend on the force there. So here now, we need to get the resultant force, the whole force, which is going to be acting on the whole of this. So why do we need to resolve them? Horizontally and then also vertically. So you see this force this is the angle. So resolve this. We start squaring this side. So I'll arm this side like this. Then I go up until when I meet this force. There. So I would have resolved this. So now we say we are going to use always our saw towards simplify life. We say now we start this angle, this is going to be adjacent. And adjacent goes with cos. So we get this cos, then cos of this angle. Then this one is going to be opposite goes with sine. So now this one is going to be 10, this one will be 10 sine 60 degrees. This is the force there, the arrow. So I've resolved now this force. This AB set for it is going to be dually, horizontal. Now I need to resolve this force. Now to resolve this force, we need to be having a horizontal. So you get your ruler and then you do that horizontal there at that point. There are many ways of doing this, but let me take you through what I think is the easiest. Now, what I'm going to say, that now this line here is parallel to this. So these two are parallel. Now, if they are parallel, it means that this angle here is going to alternate with this one here, and so this one is going to be 60 degrees with the ease. Now, now I'll be having the angle with the horizontal of this force. So now, how do I resolve this? To meet this, I'll come like this, then I'll come downwards like this. So now I have resolved this with ease. So now, how did I get this? I said I'm going to do a result which is parallel to this so that I can use the idea of alternating angles. So this angle here is going to be the same as that angle. So now I have this force, the angle acting on it there. So now this is the force, I move like this, then I move like down so that I make this force here. So it's like this force, this one is adjacent. So this angle, this is adjacent. So this will be now, our force is 10, then cos 60 degrees. And so this one is going to be opposite to this, so it will be then sine of 60 degrees. And so you have resolved all the forces. Now, if I want to get my forces resolving now, this means we are resolving horizontally. Now, let us see the forces that are going in that direction. We have the first, which is 12. We have any other, so it's that the direction is like this. Anyone which is opposing it, it's going to be a negative. So, plus, you see this one is opposing, so it's a negative 10 cos 60 degrees. Then plus, you start also this one is opposing it. I think you can see it's opposing it. Saying me I'm going this side. So then plus negative 10 cos 60 degrees or so. And so this will be 12. I think we see cos 60 is going to be cos 60 is a half times this, negative 5, and minus 5. And so our x is going to be 2 newtons. Then when I solve vertically like this, my y is going to be vertically now. You see this one it's having 0. Because whenever it's pure horizontal, its y component is going to be 0. Then plus. You see those ones which are going in that direction, we have 1. Here which we have 10 sine 60 degrees. Now it's following the direction we want, going up. Now this one is opposing, so I say plus. Whenever it opposes, we attach a negative. 10 sine 60 degrees. So our y here, and press that on the calculator. What do we get? So this is going to be, I think it's going to be by now 0. I don't know if you see this is going to be 0 because this is the same as our, it's going to be 0 newtons. Therefore, our resultant force, Fr, is said is equal to x, y, our x is 2, then 0 newtons. So they are asking to get its magnitude. So the magnitude of the resultant force is going to be the square root of, we square this, plus we square the y component, which will give us 2 newtons, and that will be our magnitude. And the direction, of course, the direction is going to be just this. You see it's acting along this force. So it's said the resultant is, the resultant is 12 newtons in the direction of, in the direction of AB. Why do we take AB? Because it sits in the positive direction there, and we have got this as positive, so it's going to be the direction of AB. And so that will be our conclusion. So we are going to see now more examples about regular polygons, how to resolve the forces, regular polygons. See you there. And please remember, don't forget to subscribe. And if you want all the lessons, please just visit the playlists. You go to my channel and visit the playlists. You'll see all the topics arranged properly in their order. See you there.